In this network, we have to solve using the mesh analysis as per the question. So we can first step is we can simplify the network by using the source transformation. So when you use the source transformation, we can reduce the network. This 10 ampere and 2 ohms can be replaced by this branch, okay, of the circuit elements. But you can also apply the mesh analysis in the given network directly, but there when you apply the mesh analysis directly in this, you have to consider about the current source, where you have to treat this one as the super mesh. So with that super mesh, it will be a little bit complicated to solve. So what I have done here is I'm doing the source transformation for this 10 ampere and 2 ohms resistance, and then I have represent the circuit with the simple one. And then after this, I can apply the mesh analysis, and I'm assuming the mesh current I1 and the mesh current I2. So at mesh 1, which is at the current I1, you have 5 of I1 plus 2 of I1 minus I2 plus 20 minus 50 should be equal to 0. This is as per the KVL. So which means now you will have 7 I1 minus 2 I2 is equal to 30. So this one will be our first equation. And for the second equation, or at the mesh 2, you have 3 of I2 plus 10, 10 minus of 20 volt plus 2 of I1 minus I2 minus I1 is equal to 0. So if you simplify this one, you will get minus 2 of I1 plus 5 of I2 is equal to 10. So this is our second equation. And if you solve the equation 1 and 2, using any method, so I'm directly solving equation 1 and 2 using the calculator. So while solving this one, I get I2 is equal to 5 point I2, this is I1 is equal to 5.48 ampere. And similarly, you can also calculate for the I2. So when I use the calculator, two unknown equations, 7 minus 2, 30 minus 2, 5 and 10. So I1 is 5.48 ampere and I2 is equal to 4.194 ampere. So now through the 50 ohm, through the 50 volt, or through this one at the left hand side, through this one, that's the current I1. So this one will be our answer.